This is a real wine seminar. There are some science in here, but I try to keep that very short. And the reason why we'll talk about lost continents is that I made a list of all the projects I was working on, writing papers, and it turned out to be 23 simultaneously. And trying to structure myself, I thought I'll now try to finish the one I worked the longest with, and that's this case. This goes back 12, 13, 14 years. So sometimes science can be very slow. But maybe we think we have the answer now. So I talk about lost continents, and I'm not really going to talk about Atlantis or me, which I learned about. But I'll try to put it in that context. There are some Italians who think they found Atlantis. Just look at what oceans. So this me was supposed to be in the Atlantic Ocean and later in the Pacific. And if you look at Atlantis, it's in the Indian Ocean, but it's more in this part. And I will show you, we have found these lost continents in one of these oceans. And you will see which one. Where is this? Is it this? All right. Some of you have seen these. I will show some pictures which some of you have seen before. But what we're really going to address, we're going to look in the Indian Ocean. So here's South Africa, here's Madagascar. And what is really important here is, this is what we call the reunion hotspot. Do we have enough lights now? Huh? It's okay? Ah, okay. Yeah, it's all this filming. So I will show you around here, because since I'm a geologist, we have to do field work, and this is probably one of the better areas to work. And if someone wants to switch from physics to geology, we have a lot of projects here. So we'll talk a little about present-day hotspots, and I'll come back to what that is. Reunion. Here is Mauritius, which would be very central to the story. Another place we've been working is the Seychelles. And then we worked in India, so this is around Bombay. And you will see in the end where we are planning to go next time will be the Maldives. That's going to be the big operation and a very expensive operation. There are also a number of other here. So what are we talking about? So what is generally believed is that we have a present-day hotspots today coming from the deep mantle, and 65 million years ago, this part of India was just sitting above this thing. So you got these, what we call the Deccan tracts. It's a large igneous province. This is catastrophic melting of the upper mantle, and it can produce pretty bad environments. And you know also the dinosaurs has been linked to this one, although many favor an impact right now. So it's really a story from going back. I will go even further back. I will go back 1 billion years. But it's really, the focus is from Deccan to the present-day reunion hotspot, which is active today. Here we go. So just a little science, not very much. Some of us think if we look at all the way down in the top of the core or in the lower mantle, almost 3,000 kilometers down, we have these two red blobs at the core mantle boundary. And we think it's these margins here which actually source plumes like reunion hotspots coming up or large igneous province. So this is kind of our working hypothesis. And one of the reasons why we haven't published this from the reunion, or when we reconstruct this Deccan trap, it falls about here, which is very close to where reunion is today. And one of the reasons why we haven't published this for 12, 14 years is that we run into a number of problems to fit into this kind of theory, which I kind of like. And I'm very frightened publishing this because people might think this is not true any longer. So we have a little problems, and you will kind of see what the problem. Since this is a wine seminar, I won't talk too much about what methods we do reconstructions. The only thing you have to remember, we are using Euler theorems, the spherical geometry, and what is most important in this talk is actually dating Zircon. So this is Fernando's lab, I think. I just searched for a lab. This is your lab, yeah? Looks like it. Okay. So we're not going to talk about isochrons. You heard that last Friday. We just talk about numbers. But dating these zircons in rocks is very important. And because of the nature of the fieldwork, a lot of the sampling will be having the right swimming gear, and also we are drilling rocks. Slightly smaller than this one, but so drilling, swimming, dating rocks is kind of the fundamental. Just briefly about the science. So we think, for instance, this Reunion hotspot at the surface today, it's fed by one of these plumes coming from the core mantle boundary, but it's not coming straight up because the mantle is very slowly convecting. So maybe this is kind of more realistic. It actually, it's fluctuating or advected in the mantle. And that has been known for a long time. Go back to Tusa Wilson, one of my big heroes, 1963, the first one to suggest that. He suggested it came from the upper mantle, not the lower mantle. But Jason Morgan said it was from the lower mantle, and he then introduced, at least the year after, the first what we call hotspot reference frames. And then Bernard Steinberger, who's a professor too here, has developed these methods where they actually are not coming straight up, but they are slowly advected in the mantle. So that's the kind of simple theory for these things. So now, lost continents in the Indian Ocean. So we'll start in the Reunion. And most people who work with the geochemistry there will say this one has the true signature of something potentially coming from the deep mantle. So we're not really worried too much about this one. And here are some beauty pictures. And where's Olivier? He actually went to Reunion. Oh, is he? Okay. He actually went to this place a few weeks ago. So we should have gone with him, you know. So this is from 1975. So this is truly an active hotspot. Might have been active for 65, 70 million years. Then we go to Mauritius. So this is the first island in what you can call the Reunion hotspot chain. The lava there varies from practically today to about 7.8 million years. In the Reunion, you have had magmatism for about the last 2 million years. We try to look into the geochemistry there, and it's a little more complicated in Mauritius. Some people have been saying maybe there are some mantle plume or plume lithosphere interaction when they look at the geochemical signature, and you will see later that's going to become quite important. So Mauritius is not a bad place to go. So here you see it. So these islands here, the oldest volcanoes are about 7.8 million years. So this is what it looks like. And I'll show a few pictures. We have been on many field trips. I'm mixing trips here now. This is the first trip we went to Mauritius. So this is a view from our room. And this is Björn. He was exercising. And I've told this story before because we arrived in the night and Björn was worried if we needed to have a rental car to find these lavas. But I told him in the morning, I was standing on the balcony, that we could just sample the garden. But Björn said at least we had to rent a car, so it looks better with the Norwegian Research Council, that we actually had some bills except for the hotel and the bar bill. So we actually went somewhere. I can't even remember where we went to sample, to be honest. Do you remember where on the island? Did we? Okay. Somewhere here, I think. So this was the hotel. Very expensive. This is one of those where you have a full package where you get a dinner in the hotel, and after 9 o'clock everyone disappeared. They went to the room to drink their tax-free, because even a Coke in the bar here, and this is in 1998 or something, it was like 100 kroner just for a Coke. So that's why they all ran away, and it was totally... I do not recommend you to go to Mauritius if you want to interact with people, unless you have a lot of money. Okay, so from that sampling, and now I told you now these are lavas. It's the first island in the chain, and the oldest lava is 7.8 million years. And it's not that easy to find zircons in lava, but when you look at the ages, just look at the numbers. So you see here on the Concordia 275, 280, 300. That's very strange. Because if this is a hotspot chain and you find zircons up to 300 million years old, you have a problem. So here was one of the conclusions, when these zircons demonstrate they formed during early Permian, but reworking of Proterozoic continent. What we were saying, there must have been a continent beneath. Beneath these basalts, which you are seeing, there must have been continental crust. So when that plume came, it grabbed these zircons and brought them to the surface. And you will see, that's still what we believe, but the only problem here, these ages are all wrong. They're contaminated. And they look suspiciously like ages you will find in the Oslo rift, or something like that. So,
it was the age of the samples that was crushed before those?
Before those, probably, yeah. So it's not the right rocks. But it was submitted to Nature, 21st of December 2000. Yeah, not Fernando. This was not Fernando, that's important. Now Fernando is here. This was this man here, Ulf Schaltegger, who is normally quite renowned to be a reasonably good dating man. So during the process, you actually dated something which has been crushed before. Then you have a problem. If you remember now you're in the middle of the Indian Ocean, if you got a really funny age and you want to have a continent, at least you should find an age which looks like something in the neighborhood. Do you find the same rocks in India or Madagascar or Seychelles? And there was no age of this, so we had to kind of make up something. So here comes the really crazy early Permian basins and rifts trying to understand these ages. But be aware, nothing in the Indian Ocean around there. We had to go to Namibia on the other side of Africa to find some rocks of the same age. This one got rejected, luckily. Or it would have been
It was up for review and
it went for review, and they were not bad. It was just about. But there was one referee hinting for that they were contaminated. And luckily, so this was, he was really the man behind this, but he is now in astrobiology. So, and he's actually in NASA now to watch the shootout tomorrow, where they're going to send some rover to Mars. But he was the one pushing this, and I guess it was his original idea too. Yeah. Was it, Björn? No. Yeah. So that's why the two of us went, and we had Lou Asheville, and we had a per student with us. You will see a picture of later. So this was kind of the beginning of this madness, 1998. So that's 13 years ago, or something like that. Okay, so I will come back to that. I will come back to this crazy story. Then I go to Seychelles, because here is supposed to be rocks. You will see later, when we reconstruct all this thing, this Seychelles here and down to the Mascarenes Plateau was actually sitting next to India. Okay? So if you have some sort of 60, 65 million years here, you would expect to find it in the Seychelles. That was trip number 3 or 4. We had been there before doing other, but on the very last trip we went. So here's the Seychelles. This is a cool island. It's mostly granites, and you will see this is the most dated paradise on planet Earth, because we have been there so many times. These granites are practically without 2 H's, 750, all of them, you will see. So this is Seychelles, and there you also need a lot of money. It's not cheap, but it's a little better than the Mauritius. So here you see some pictures, and this is Björn when he was a little younger. Here's Lou Asheville. But that's from another trip. The one I'm going to show you is going for these. So we had master students. She's now turned that into a PhD. Tricia, and I guess that's Tricia. Is it Stephanie? It's not you. That's Tricia. So it was really to take this young girl to paradise and look at some rocks. And so here's the dream team. So this is 2008, so we worked there. We also took with us a young student, and he was very excited going to the Seychelles, so there's some flying down there. So there is Morgan Garner, this is Lou Asheville, this is his girlfriend Sue, that's me, when I was a little slimmer, or I don't know which way is going. And there is Tricia, and there is Stephanie. So we went to these islands to search for these rocks which might be Zircon. And I told you this is a paradise, very well dated. Sorry, this is a Norwegian earlier expedition area. And you see 752, 753. We should have been bored by now. But you go back. But there, wow, we found a funny one. 703, 755, 53, 56, 52, and there should be another. Oh, here's another one. Hey, so we have two anomalies. But you could say these rocks, these are granites. There are some basaltic dikes as well, but these are 750. And this is important because when we go back to Mauritius, we got these H's 250, 300. It didn't fit anything. But you will see later this becomes very important. Also, so all this solid work here becomes very important.
You missed one. South of St. Anne, you didn't date that.
Which one? Where is it? Oh, yes. Yeah.
We have to go back.
We might go back. And I tell you, these islands, most of them are actually bought by people. They're private. They're luxury hotel. Where I'm going to take you now, we go to Silhouette and North. And North, for instance, they have a hotel, and with our crew, and I asked for a price for the crew for a week there, and they came back for accommodation was 1.5 million kroner. And okay, we only had a few 100,000. So, and that's where superstars. So when we were on the beaches there, first they'd send someone in the front and radio if it was clear for us, dirty geologists, and we had to eat with the crew. It was like a bad kind of English. You've seen these English stories 100, 200 years ago when you have to eat in the basement with the servants. And I didn't like the food either. So we had to stay here in also a good hotel, but we had to take a boat every day, which was not cheap either. That's like $1,000 or $2,000 every day to be taken out. So here's these islands. So you can see all these 750s, and these are the one which has a relation to the big Zircon. So just some feel for, and these are tiny islands. You can map them out in a very short while. So here you see this boat we're taking out every day. And the only good thing with taking Lou Asheville in a boat, I think that's him. He talks a lot. The only time he's shut up is in a boat because he gets seasick or quiet and he doesn't talk very much. So take him in a boat if you want to keep him, stop talking. So again, I'm not going to dwell on, but you can see, so this is work of Fernando. Fernando never went on these. He likes to go to northern Norway and exotic places like that. But you can see some of these rocks here, 63.5, there's 63 something. They're a little younger than the Zircon, but these are also very different rocks. They're not basalts, they're more acidic. You see cyanide, microcyanide. So this is kind of a late phase of Zircon. But that's very often in these slot igneous province, or rifts that you start with these basalts, and then you get more acidic rocks towards the end. So these are argon H's. That's done in a slightly different way, but I'm not going to explain it to you. But it's 63, 63. But you find these kind of. So that was a little more. That was a little more normal. You get something which you expected, not you go to the first island where you expect to be below 7, 8 million years, and you get 300. So this is a normal field work. Okay, so this is just to show you, I will come back to this, if you go back some 65 million years or whatever, we had India here, we had this Zircon trap in the Seychelles, we're sitting very close to it, and we were on some islands here and showed that you have H's which kind of can confirm this theory. Not a big thing. It was more a holiday, really. So now we are leaving the Seychelles, because now of course we have to go to the Zircon. Now we've been talking about all this relation, so we have to go to the Zircon tracks. So now we're going to India, which is not that exclusive. So we are flying to Bombay, and this is a typical day in India, or what it looks like. I'm not sure if it was a bomb or what, or whether it's real. So this is these are real pictures, what you see from the plane. So here's India. This is when we arrive. I think we had to put a luggage somewhere for storage. I can't remember why. this many years ago. And here are some typical pictures. I had a haircut from an Indian guy who didn't understand a word English, but he had a list. It started with something looks like haircut, and halfway the list there was massage and electrodes or whatever. But I told him to stop when he came through most of the list. Okay, so here's the famous Deccan tracks where we were heading. Unfortunately, we never got there. The only closest we got to Deccan tracks are here. This is the fireplace in a bar in Bombay. So this, so this is the closest touch feeling I've had with these rocks. We did not sample it. So obviously here is another target where we have to go back, because we never got to this place. It wasn't actually our plan either. So there's a lot to be done. We actually did something else. So again, when Björn was a little younger, shorter hair, we were a little miserable. We had to be vegetarians for a week, I think, because we were in the vegetarian part of India. Actually, we didn't look at these Deccan. We looked at some older rocks, which is also going to be important now for the Mauritius story. So here's Björn drilling. So we're drilling something called a Malani. And there are also a number of granites there, a lot of dating we did there. So we wrote a paper, at least we wrote some paper. We talked about Rodinia. And in the Precambrian, most of you have heard about Pangaea, which we had known about 100 years. But before that, we thought it might be another supercontinent. We called it Rodinia, which should be in existence in about 750 million years. So that's the kind of rocks we actually were drilling up here in India. So we wrote this paper, and this Manoj Pandit is very, very happy with this. Every time we meet him, he says, this is the most cited paper in Indian geology. And he's very excited. So we believe him. So we went to these rocks there, and I told you now there was 750 million years here, and the rocks we were working on Rajasthan turned out to be 770, so that's kind of a magic number to remember. Because now we're going to go back to Mauritius after we realized there was some trouble with these 250, 300 million years in these young basalts. So this is phase 2 in Mauritius. Good thing when you get things wrong, you can go back. But this time, so here is Mauritius part 2, still looks the same. But this time we sent an Arctic explorer to get it right. So here's Eberhard, and I think he had his children with him. Because when you look at these little thing there. Okay, so what did we do now? Well, when me and Björn was there, we had hammer and we had these big rocks, and we put in a rock crusher, and obviously we dated something else which was in the rock crushers. So now is plan B. Let's collect basaltic sand, beach sand, which is eroding on the spot, so we don't have to go and do rock crushing. So we avoid this contamination. So that's why these special tools, and found zircons here. So with the help of Eben, that's why he is also involved in this. Oh, did he? Okay. Yes. So now we had some competition. 3 of us had been to sample, and so when we started drafting the new paper, there were a little warfare. If this paper ever goes out, who's going to be the first author? Because, hey, I've been there, and 3 of them said I've been there. And in the end, Björn gave me the task, and I made it alphabetic, and that shut everyone up. We changed it a little now. But originally I made it alphabetic, so that, and with my name, Trosvik, I became the last, so nobody could complain. But we'll change that. Anyway, so now it's beach sand. We don't have these problems with rock crushing. And now you will see. So don't worry about... so now you look at this Concordia diagram, but now you see here, these are now very close to other H's, 700, 900, 1100, 1300. You see, we still find these old zircons in these very young basalts. So still, they must pick something from a continent. But now we're getting H's, which are much better.
We also have the right man to do it.
Yes, and now we've got Fernando, who probably cleaned his lab and changed some clothes before he went for this very exciting study. But you see, now we have good ages, because I've told you we were here and we dated all these rocks. If we have granites and basement here, maybe there are blobs of basement all the way. Remember, when we started here, this was just supposed to be a volcanic chain over a hotspot, okay? Plates moving over. But we always known, this Wegener discovered that in 1925 he came here and said, hey, this is a continent, it's granite here. And of course everyone, if you go there, but here, for instance, everyone thought they're purely basalts. There is no continental crust there. So when I use the word lost continents, it means something else. It means continental crust, okay? Not oceanic crust. But now in business, you see these ages here, because they are now getting very similar to, for instance, this stuff here, and there are some older. And so now I'm just going back to the Seychelles, because these 750 ages are these kind of rocks, which we sampled on various islands, and here you see how we had to go on and off these islands with sample. But this is to get the basis that these rocks are 750 million years. So here is these papers we published. So here is 750, 52, and here's a dike as well, 750. So now we have rocks in Mauritius which actually resemble these things. So if there is some continental fragment, it's really good that it looks like something which is in the Seychelles. But it's not exactly, but you have the same kind of ages. Plus something else. But these are probably reworking ages, probably anyway. But so now, if we go back in the really good old days to about 750 million years, this is what we think it looks like. Here is Madagascar, here is India, Seychelles was sitting around here, and then we think there was a number of these lost continents, probably all filling in here. They were actually Madagascar, India, crustal, which is continental crust, okay, with also intrusions, probably of these 750 stuff. But there is also a deformation event at that age as well, but now everything fits. And we can almost say they shouldn't go further down than here. The reason is because there is a young, what we call a Pan-African orogeny effect in this area coming here, and these, but then you would expect to get reset ages of about 550, 600 or so, and we don't see that. So we think they were all to the north of this. So that's why it was important to, even though we didn't look at Deccan, we looked at these rocks in India. Here they are from the Seychelles. We also been to Madagascar, but I only went once to Madagascar and decided I will never work there again. And this is not a happy place to work, and it's also mildly dangerous. So here is if you can call it a little conclusion. We found this Zircon. So here is this hotspot track. I'll come back a little. We can make a synthetic model, and this is what Pavel, who is here, has been doing. From a global model, he makes an expectation, if this is a real true hotspot track, where would these continents be at the reunion 10, 20, 30, and then because you had an opening here, jumps to the other plate. So this was supposed to be all young basalts, but we found these zircons. Some of them are probably more than 1.9 billion. That's not a problem. That's the kind of ages you find in India and Madagascar. But they also have these Neo-Proterozoic ages, so 840, 660, which fits very nicely with stuff from Seychelles and further up. Okay, so we had 20 zircons, and saying there is a continent, some people might think that's a little weak. So what we done, we got Nick Kushner, of course it would be lovely now to do refraction seismics to get the crustal thickness and get all this thing done. We couldn't afford that, but luckily there's something called free air gravity, and I'll say free air gravity. And if you know how to deal with that, you can actually do a rough calculation what the crustal thickness are, and you do some corrections. And so here, did that for the entire Indian Ocean. You see these colors. So when I get into kind of red-gray, it means you have a thick crust. And you can see that here on the Mascarena Plateau, of course a lot of it it's probably mostly basalt, but we think it's a combination of continental fragments, probably stretched, maybe down to 20 kilometers, and then basalts on the top. You can also see here and also in the Maldives. That's why Maldives is going to be one of our test areas to go to. And then when you go to the oceans, typical oceanic lithosphere is 5 to 10 kilometer. True continental lithosphere is about 35. So whenever you see this kind of color up here, we think, and here we know it. Here is seismic across it. We know the crustal section is 35 kilometers. So we have some calibration point. And there is also some elements here which also are probably clearly continental. So that kind of backs up the story. And then we do a lot of reconstructions. For instance, we also said, hey, look at that thing here. It's called Chagos. If you follow, so here is the fracture sounds in the oceans, okay? If you simply reconstruct that backwards, doesn't that fit nicely into this thing? So if this is continental, or maybe some fragments here, maybe this is as well. And it actually broke apart here. And you can follow about 40 million years. So that's our postulate. Still, we don't understand all this stuff here, but we're kind of getting it together. So, I show some reconstructions. And these are, you've seen Pablo around, so he's just about to submit a paper very soon, and we are using these reconstructions. And you see he's made reconstruction back to 120 million years. This is all the plate kinematics, and there are vectors, and it's all based on fitting hotspot track, and here is the reunion track, but he has 5 of them. This is just one of them, but this is based on what Pablo is doing. Look. Right. So, based on these reconstructions, then, I'll give you a little kind of paleographic cavalcade. I want to drink it, don't I? So, we will now talk about, so we call this Mauratia, since we came from Mauritius, all these fragments. So that's our new name for the lost continents, Mauratia. And we postulated it was never found before. We were looking in the wrong places, realizing that we started to look for the spot where an entire Zircon could be hiding itself. Geology afforded a correct and different answer, down under the Indian Ocean. So this is our working hypothesis. And I just show you, we can now trace this lost continent for a very, very long time. We can start 750 million years ago, or like here. So these lost fragments was then part of this supercontinent. They were sitting between, they were probably India, Madagascar was probably one continent together, and this lost continent is probably just stretched continental crust, which was broken up and distributed into them. And then it was flooded with lava, so we can't see them. So that's what I mean by lost. We cannot see them with normal means. If you go to a slightly younger time, Mauratia was also part of another semi-supercontinent. I've turned it here so it's easier to see India. This is about 480 million years. So here again you see Madagascar, India. So Mauratia became part of what we call Gondwana. And then it's very boring. Nothing happens in Mauratia for a very, very long time, until about 83 million years ago. Then we can pick up the history. And this is some reconstructions Carmen has done, but we are using now the absolute reference frame of Pavel. So we are at 83.5 million years. So here is all these little bits and pieces. There's Seychelles, which now are underwater or covered with basalt. And at this time, we probably had a big plume, similar to the reunion, in the southern part of Madagascar. And actually, the entire Madagascar, this is about 1,600 kilometers long, was covered with flood basalt. So that was not a happy place to be. We know that because we've been working there. We've been dating this event. And here is Lou Asheville sitting on some of these basalt. So that's from an area around here. Of course, because of erosion, not everything is preserved, but you can imagine this entire thing was flooded. And also offshore, there's a huge plateau offshore, Madagascar plateau. So this was a very big volcanic event. Probably also affected Seychelles, so we've been to Preslin, we haven't published that yet. But also affected part of India, so the reason why I show you, this Mauratia might have been affected. There might actually also be volcanism of about 90 million years affecting part of these things. Because now this is all together, but it's going to break up now. This is the first breakup anomaly, about 83.5 million years. And I'll show you that, and of course it's important to go everywhere in this part of the world, and of course we have been there. We were the first one to discover this, because everyone, there was some funny, remember the Deccan, the big Deccan is supposed to be 65 million years, but there was some rocks along the coast here, which had slightly older ages, but people said, oh, it's the same, it's Deccan, it's predating. So we went to check that working hypothesis. And this thing here, and that's not a bad place either. So we go to Mangalore in India, which is about here. Very hot place. So here's Mangalore. Some of the beaches. We went with boats, again Björn and Lou, and it was very hot there, 40, 45, I have no idea. Remember, we had drilling. After half a drill core, I had to hand it to Björn. The rocks were very hard and it was very warm. Not a happy. But these are beautiful rocks. These are actually rhyolites, columnar jointed, beautiful rocks. But they are very hard to drill them. It's almost like the drill comes back on you when you try to do these things. So rhyolites can be extremely hard. And I show you this kind of reconstruction with this 90 million years. So we dated this. This was not Fernando. This was done by a guy called Bob Tucker. I don't work with him any longer. We had a divorce some years ago. I actually had a divorce with all of us, so I don't know who he works with any longer. But he's not a bad man. So we trust his ages, but you see it's about 91. So this is not Deccan. So this Mauritius was clearly hit by something there as well. Then I jumped to 61 million years, and so here is India. Seychelles was around here. So this is kind of a reconstruction. So this is what we call Mauritius. All these blobs here, it's very complicated, spreading history and aborted rifting. We're trying to build a model how to get this thing together. This is very premature. It's kind of done over the last 2 days. But this is how we are trying to build up this picture, how this Mauritius involved. And so this was 61 million years, this is 41 million years. And now, when I'm trying to illustrate here now, we had this little Chagos block, which is now part of India, was part of this Mascarena plateau, and we're now trying to model, we're saying it's actually splitting away. These two are going away. And now this is kind of the lost thing. And when time involved, these continental fragments get just flooded with basalt and sinking underwater. You know, they're submerged. So they're all lost. So maybe it's like a Pompeii if we can get under these basalts and see what happens. So this is the last, so this is our web page, Mauritius and the Lost Continent Finally Found, where you can check up the expedition team, and we have a book. Of course, I'm joking now. So this is about 16 million years, what it looks like. And since this is about red wine, I'm not going to dwell into too much of this. But what's the next step? So we postulated we have found this lost continents. They're either submerged or you can find them on Mauritius. That's an island, you can go there, but it's covered with lavas. So how can we test this hypothesis? Of course, we can shoot seismics too, but that's kind of you're imaging. You can try to get proper crustal thickness, so forth. But the only thing we can do is to drill. We have to drill. We have to drill a lot. We need deep drilling. So to test our prediction, we have to do some experiments, or we have to modify our hypothesis. Luckily, things are moving in the right direction, but I might be dead. Norway and Europe are designing to build. It's not a normal drilling ship. It is actually it's an icebreaker drilling ship. It would only cost I can't remember 7 billion kroner. But you see, we are always optimistic. And since I'm now part of the science plan, but what I gave them last week was not the Indian Ocean, because it's supposed to be Arctic, so this was my suggestion, because they are similar to this reunion in saying there are things along Antarctica here. So this is these targets. Also look if there can be continental components in these kind of basaltic provinces. 7 billion kroner, it's only an opera or 2 operas or 1 Gardermoen train. It's only a few Holmenkolls, I think. Yeah, remember Holmenkoll, 1.5 billion for some people go there for a week a year, okay? This is cool stuff. So I strongly recommend that this would be built. And then, otherwise we have an alternative plan. And so now we're getting into the final year of PDP. To test this prediction, you see one of the islands involved in Mauritius is the Maldives. So this is what Maldives looks like. And we will discuss with the Norske, since that's sponsoring Sergei. But I seriously doubt that they will let a ship come in here in the lagoon and do deep drilling for a couple of weeks. So testing this prediction here could be mildly entertaining. But I've never been there, but I found on the web page someone just said, awesome, heaven on water and in water. So this should be as good as the Seychelles or Mauritius. And I think, so that's the last one. So what's next? Well, when we first tried to publish this story, it got rejected, luckily, because we had the wrong H's. And there was many things we didn't really understand. A few things we still don't understand. But we'll try again. Science or nature should be material. And I just got an email today. We are pleased to announce early for a 3-day how to publish in peer-reviewed journals. I don't know why I got this. I have published a few papers. But maybe it can help us, because point 1 was identification of reasons for rejection of papers. So maybe we should go to this course in Germany in February. It's amazing what you get on the email. So that's Mauritius, the lost continent finally found. So that's it.